Next is question number 81, which says that the number of ordered pairs x, y, where x, y are belonging to n and satisfying the equation tan inverse x plus sine inverse 1 upon under root of 1 plus y square is equal to cos inverse 1 by root 10. So we have to find the solutions of this equation. Now, firstly, we here see that sine inverse 1 divided by 1 plus y square. We can write it equal to, let's make a right triangle here. Let's say this angle is theta. This is 1 and this is under root 1 plus y square. So this will be y. So this can be written equal to tan inverse 1 upon y. So the question have become a little simpler. So we have got tan inverse x plus tan inverse 1 by y is equal to, now again, cos inverse 1 by root 10. So this will be equal to 3. So it can be written as tan inverse 3, right? So it can be written as tan inverse x equal to tan inverse 3 minus tan inverse 1 by y. So this will be equal to tan inverse 3 minus 1 by y upon 1 plus 3 by y. If 3 by y is greater than minus 1, which is true because y is a natural number. So we can write it equal to tan inverse 3y minus 1 divided by y plus 3. So on comparing the arguments, we will get x equal to 3y minus 1 divided by y plus 3. Now the only values of x for which x and y both should be natural number is 1, 2, and corresponding to that value of y will be equal to 2, 7. So the ordered pairs are 1, 2 or 2, 7. So we have two ordered pairs here, which means that answer will be option number 3. Next is question number 82, which says that the value of tan inverse sine 2 minus 1 divided by cos 2 is. See, here sine 2 minus 1 upon cos 2, which can be written equal to minus of cos 1 minus sine 1 whole square divided by cos square 1 minus sine square 1. So this is equal to minus of cos 1 minus sine 1 divided by cos 1 plus sine 1. So this is equal to minus of, dividing by cos 1 in the numerator and denominator, we will get 1 minus tan 1 divided by 1 plus tan 1. So we have the value of tan inverse, minus can be taken out. So we are left with 1 minus tan 1 upon 1 plus tan 1. So this is nothing but the formula of tan of pi by 4 minus 1, right? So this will be equal to minus of pi by 4 minus 1, that is 1 minus pi by 4. So from the given options, it can be seen that option number 3 will be the correct answer. Next is question number 83, where we have to find the domain of the function fx equal to sine inverse greatest integer of x minus 1 divided by x. We know that for sine inverse theta should go from minus 1 to 1. So we can say here that greatest integer of x minus 1 divided by x should go from minus 1 to 1. Now we have two possibilities here, that is either x is greater than 0 or x is less than 0. For x greater than 0, the inequality will not change and we can write it as minus x is less than equal to greatest integer of x minus 1 is less than equal to x. But for x less than 0, the inequality will change. So we will write here greatest integer of x minus 1 will belong from x up to minus x, right? Now greatest integer of x will go from 1 minus x up till 1 plus x. Now greatest integer of x can be written as x minus fractional part of x. So that goes from 1 minus x up till 1 plus x, which means that minus of fractional part of x will go from 1 minus 2x up till 1, that is fractional part of x will go from -1 up till 2x minus 1. Now this inequality can be solved by making graph of all the three functions for x greater than 0. Now firstly the line y equal to -1, that will be here. Also y equal to 2x minus 1. For x equal to 0, y is -1, and for y equal to 0, x is half. So the line will be like this, where this is the point x equal to half. Now graph of fractional part of x, that will be like this, where this point is 1, 1, right? Now fractional part of x should lie between y equal to -1 and y equal to 2x minus 1, which means that from the graph x can go from 1 up till infinity. I hope this is clear. Now from the second inequality, that is x less than 0, we have greatest integer of x should go from x plus 1 up till minus x plus 1, that is x minus fractional part of x should go from x plus 1 up till minus x plus 1. Subtracting x, we will get 1 is less than equal to minus fractional part of x is less than equal to minus 2x plus 1, which means that fractional part of x should go from 2x minus 1 up to minus 1. Now we know that fractional part of x is never less than equal to minus 1, which means that from here we get x belongs to 5. So taking union of both, we will get x belongs from 1 to infinity. So from the given options, it can be seen that option number 3 is the correct answer. Next is question number 84, where we have to find the fundamental period of the function fx equal to cos of cos x plus cos of sin x. Now here we know that for period fx should be equal to f of x plus t. Now if we find f of x plus pi by 2, so that will be equal to cos of x plus pi by 2 plus cos of sin of x plus pi by 2. Now as we know that cos of minus x is equal to cos x, so we have cos of sin of x plus cos of x, that is equal to fx. So it means that the fundamental period of the function is pi by 2. So option number 2 is the correct answer. Next is question number 85, which says that the number of values belonging to the range of fx equal to sin inverse x minus cos inverse x plus 2 plus tan inverse x plus 1 is. See, in these type of questions, firstly we have to find the domain of the function. So here for sin inverse x to be defined, x should go from -1 to 1, and for cos inverse x plus 2 to be defined, x plus 2 should go from -1 to 1, which means that x should go from -3 up till -1. So from 1 and 2 we can see that the only value that x can take is -1. So f of -1, let's find it. It should be equal to sin inverse -1 minus cos inverse 1 plus tan inverse 0, that is equal to minus pi by 2 minus 0 plus 0, that is equal to minus pi by 2. So we have only one element belonging to the range of fx, which means that correct answer will be option number 2.